Hi guys, we're gonna go into um, the more boring part of culinary: recipes, conversions, measurements, costing recipes, and we're gonna talk about a lab form that we use in culinary as well in this section. So there's going to be a little bit more to do, but we're gonna have fun. We're gonna make a fun recipe that you guys will like when you've completed the paperwork. So the paperwork has to come first. So go through this section and watch the videos that we have on measurements. We'll be doing a demonstration measurement lab first day we come back from fall break. And we'll push through this unit. All right, let's give it a try. So we're going to start with standardized recipes. And what is a standardized recipe? Well, a recipe is one of the most hardworking tools in the professional kitchen. The ability to read a recipe correctly and use it in various ways is critical to the food handler's success. Strong math skills and careful attention to detail of a recipe will help you create tasty dishes for different situations, from a party of 4 to a wedding for 200. A recipe is a written record of ingredients and preparation steps needed to make a particular dish. Recipes used at home can follow any format that helps the cook prepare the dish. But recipes for institutional use, or standardized recipes, must follow a format that is clear to anyone who uses them. A standardized recipe lists the ingredients first, in the order they are to be used, followed by assembly directions or the method for putting the ingredients together. Not all recipes you find are standard recipes, and that's why one of the first things we're going to learn is converting our recipes to a standard recipe. Mathematics is a big portion of this. Arithmetic, adding, subtracting, multiplication, division, little bit of fractions in there to help you with conversions. If mathematics, most all of you guys at this level are really good at math these days, so I don't really consider math refreshers. But if you do need some help with your math, reach out to me or reach out to your math teacher, and they can help you with these as well. Standardized recipes play an important part in a successful professional kitchen. Controlling the costs, quality, and consistency of a product are as important to the success of a restaurant as the preparation and service of food that looks and tastes good. Consistent production of good food is the result of the following: a clear, standardized recipe. This means ensuring consistent quality, ensuring consistent portion size, helping purchasers to understand what to purchase, allowing cooks to understand what to prepare and how much of each ingredient is necessary, reducing waste because no one is guessing amounts, helping servers to communicate accurate information to guests, such as dishes with potential allergens, meeting guests' expectations for consistent dishes, helping managers to determine a dish's cost, which helps to control these costs. A standardized recipe includes the following information. Of course, the name. This is the title of the recipe. The yield. This is the number of servings or the amount the recipe makes. This information is useful to determine how much of a recipe quantity is needed. Yield is critical to understanding how much it will cost to produce a recipe. Next is the ingredients. Ingredients are the food items needed to make the recipe, usually listed in the order in which they are used. This list makes it easier to follow the recipe and not forget an ingredient. Each ingredient must be clearly defined. For example, stating onion is not specific enough. It provides many choices such as yellow, red, white, green, or pearl. Amounts of each ingredient are also given. Avoid terms such as to taste and as needed. Using specific amounts makes it more likely that the finished product will be what was intended by the creator of the recipe. In commercial recipes, weight is generally the preferred method for measuring ingredients rather than any other customary measurement, such as cups or quarts, or stating one's onion or a large apple, because weight is a lot more accurate. Portion size. This is an individual amount that serves one person. Temperature, time, and equipment. This includes size and type of pans and other equipment needed, the oven temperature, cooking time, and any preheating instructions. Step-by-step directions is how and when to combine the ingredients. And nutrition information is not necessarily essential on a standard recipe, but is useful. Nutritional information may include amounts of fat, saturated and unsaturated, carbohydrates, protein, fiber, sodium, vitamins, and minerals. The recipe is a roadmap for the cook. To get good results, follow it carefully. Read the recipe completely. Gather the mise en place, all the ingredients as specified. Remember, mise en place is French for put it in its place. It refers to the preparation and assembly of ingredients, pans, utensils, and equipment, or serving pieces needed for a particular dish or service. Measure carefully. Follow the instructions for preparation. And once the recipe has been made as written, the food handler can decide if the end product is of the right quality and taste. When it is clear what the recipe produces, you can evaluate the result and make changes if desired. In a recipe, each ingredient and method of preparation affects the final preparation and final product. One of the things that I want to talk to you guys about is some of the paperwork we're doing is so you can actually evaluate your recipe and make changes to what you would do next time. And I'll talk about that in my next presentation when we go over the lab forms. Here's an example of a pizza sauce standardized recipe. Across the top next to pizza sauce has the yield, the portion size. On the left-hand column all the way down is the list of ingredients in the order that they are put together. You'll see that if you look over at procedure on the bottom right there, in a 10-quart saucepan, melt butter with the oil. Butter and oil are the first two ingredients on the list because that's the first two items we're going to use. Up above the procedure, the tools and equipment necessary to produce the recipe is listed on the standardized recipe. All right. That's standardized recipes. If you have any questions about that, please reach out to me, and I will be more than happy to help you through understanding standardized recipes. We're going to do some example standardized recipes in class. We're going to be converting them, and we're going to be making what we are converting. For those of you distance edit home, please reach out to me if you're having any questions about the standardized recipes or in the next presentation when we talk about the recipe lab forms. They are a little bit different than your distance education forms, and I would like you to use those for the standardized recipes. All right, moving along, let's look at converting recipes. Convert a recipe when the yield of the recipe, the amount it provides, is not the same as the amount of product needed. For example, suppose a recipe produces 96 portions, but a cook needs to make 250 portions for a function. Professional food service recipes have a large yield. Sometimes you have to change it or convert it if the yield is not the amount you need. Using basic math skills is an easy to increase or decrease many recipes. Most recipes, even those for baked goods, can be doubled successfully. The conversion of a recipe will affect the total cost of the recipe, but not necessarily the cost of the portion. The price of the food needed for one portion, in other words, for recipe for 24 costs $5.25 per portion, then increasing the recipe for 36 of the same portion size would not necessarily change the price. When properly converting and preparing, the quality of the product produced from the recipe should not vary from the original, no matter how many portions it yields. Now, if a change is needed in the portion size, then the calculation requires an additional step. Suppose the cook wants to convert the yield to 250 small brownies. If 96 big brownies equals $1.25, I'm sorry, excuse me, let me back that up. If 96 big brownies equals 125 small brownies, divide 250 by 125, the desired yield, divided by the actual yield, to get the conversion factor of 2. The cook would then multiply each ingredient amount by 2 in order to get the desired yield of 250 brownies. The conversion of a recipe to produce more or less product can also affect the equipment needed to produce the recipe. For example, assume a recipe produces 24 portions, and it requires the use of one hotel pan to do the final pan up of the product. If the recipe is converted to produce 48 portions, 2 hotel pans will then be needed. Or suppose a recipe calls for 1 tablespoon of an ingredient. If the recipe is increased by a multiplier of 16, then the item measure could be 1 cup, as 16 tablespoons is equal to 1 cup. The cook needs a cup measure rather than a tablespoon measure. The failure to take equipment changes into consideration when converting a recipe can cause problems with the preparation. Keep in mind that larger equipment might be needed for mixing and cooking larger amounts of food. Cooking times will often need adjustments as well. One more important safety tip of some of the things that do not mathematically convert in a recipe. Anything spicy, cayenne pepper, black pepper, chili peppers, jalapeno peppers, anything spicy does not mathematically convert. Some spices do not mathematically convert, and salt does not mathematically convert. I can tell you horror stories about students who have mathematically converted such things as red pepper flakes or chili powder with some really disastrous results. It is necessary to convert a recipe from 96 portions to one of 250 portions. So here we have the ingredients listed, the amount for 96 pieces, what the conversion factor is. And we'll talk more about getting the conversion factor a little bit later on in my next presentation as I show you the conversion factor. Here is your conversion factor. You multiply this by that conversion factor and you get the amount for 250 pieces. Okay. Use this as reference for when you need to check on your conversions, and we'll be making a couple of more. Decide how many servings you need or the desired yield. Use the following formula. The desired yield plus the original yield equals the conversion factor, which is the number by which to multiply the ingredients. For example, if a chili recipe serves 8 and you wanted to make 4, then you would use the equation 4 divided by 8, which is 0.5, and the conversion factor would be 0.5. Basically, it's new over old. So if your recipe made 2 and you wanted it to make 1, it would be written as 1 over 2, like a fraction, 1/2. 2 divided by 1 in a calculator gives you 0.5. Your conversion factor would then be 0.5. So using the same example I just told you, 4 over 8, or 8 divided by 4, equals 0.5. Then you multiply each ingredient by the amount of the conversion factor, and this keeps all the ingredients in the same proportion to each other as if they were in the original recipe. Be aware that weights and volumes are not interchangeable, so when converting a recipe, do not change a volume measurement into a weight measurement. For example, 1 cup of flour does not equal 8 ounces. And we'll be talking about that in a measurement demo first day we come back. Now, one thing I want to tell you about conversion factors. New over old equals your conversion factor. If you are multiplying up, so for example, a recipe makes 4 and you want it to make 8, it's going to be 8 over 4, which gives you a conversion factor of 2. That's a whole number, right? 2. Okay. If you're converting up, your conversion factor should always be a whole number. Or it could be a 2.5, or it could be a 3, but there will be a number to the left of the decimal point, is my point. If you're converting down, for example, a recipe makes 8 and you want to go to 4, that's going to be 1/2 or 0.5. You see, there's no number except for 0 on the left side of the decimal. So it's always going to be a point number, a 0.5, a 0.2, a 0.125, depending on how far down you're converting that. Good way to check your math to make sure you did it correctly. If you're going up, it needs to be whole number on the left side of the decimal. If you're going down, just a decimal. Okay. Always as needed when converting, convert your answers to logical measurable amounts. Think about the equipment you'll be used for measuring. And that concludes converting recipes. Let me know if you have any questions. We'll be working more on converting recipes in our next presentation and in the classroom. But for those of you at home, you don't get the benefit of our class labs. Let's look at U.S. and metric measurement systems. Typically, the U.S. has never switched over to the metric measurement system, but you are going to, the longer you work in culinary, or maybe you're going to go on to baking, the longer you're working it, the more you're going to see more metric measurements show up. The standard bake shop these days is almost exclusively using the metric system. It's an easier base 10 method of measurement than the standard U.S. metric system. The rest of the world is pretty much using the metric system. The U.S. is the only one that's going kicking and fighting into that future. Let's talk a little bit about the U.S. metric system and see the differences. The most commonly used system of measurement in the United States is based on the customary units. Some examples of these units are ounces, teaspoons, tablespoons, cups, pints, gallons, and most American recipes are written using this customary amount. And there you see on this slide teaspoons, tablespoons, cups, and all their abbreviations. The weight would be ounces and pounds. Degrees are Fahrenheit, and in length we deal with inches. So we have volume, weight, temperature, and length there listed on this slide in the standard system. Cooking and baking requires an exact weighing and measuring of ingredients to ensure consistent quality and minimal waste. It is important to understand that the same amount can be expressed in different ways by using different units of measure. This is called an equivalence. For example, 4 tablespoons of flour is equivalent to 1/4 cup of flour. Table 14.3 shows the customary units of measure commonly used in the United States and their equivalent to each other. And that would be listed right here for you. So 128 ounces is 1 gallon, 4 quarts, 8 pints, is 16 cups, is 256 tablespoons, is 768 teaspoons. Please do not convert teaspoons up in my program and leave it as teaspoons, because if you converted it up and it turned out to be 1 gallon and you listed on the recipe as 768 teaspoons, I will stand you over a sink and have you measure 768 teaspoons of water. Don't leave it in that conversion factor. Change it. Change it to something that's easily to work with. Think about how you would like to measure it. Would you like to stand over and measure 768 ounces, or excuse me, 768 teaspoons of anything, 1 teaspoon at a time? Or would you rather just grab 1 gallon measure and measure out 1 gallon? Think of what you would rather do, and that's the measurement I want you to put it in. Customary units of measure commonly used in the United States and their equivalents to each other is listed on this slide, so you know. Be familiar with these. You're going to be tested on them all through culinary. The metric system. The metric system is a standard system used in many other parts of the world. It is also used by scientists and health professionals. Metric units are based on multiples of 10 and include millimeters, liters, milligrams, grams, and kilograms. For example, just as there are 100 pennies in a dollar, there are 100 milligrams in a gram. So it's base 10. Kind of simple to see. Here on this slide lists volume, temperature, weight, and length, and how they are measured using the metric system. Some of you are familiar with the metric system and have used it in other classes. It's used in science classes a lot. So I'm not going to dwell too much on the metric system. I just wanted to share with you how it works in the culinary kitchen. It's very important to be familiar with both systems of measurement. As long as the correct measuring equipment is available, it is not necessary to convert measurements from one system to the other. If a recipe is written using metric units, use metric measuring tools. It is helpful, however, to understand some common equivalencies. For example, 4 tablespoons of flour is equivalent to a quarter cup of flour, or about 60 milliliters. What is super important is you get down to 1 teaspoon and you want to weigh 1 teaspoon of something. It's hard to do, but you can weigh it based on grams using the metric system because it's a much smaller unit of measure, so it allows you to do so. The next thing about metrics is converting Fahrenheit to Celsius. Rarely do we have to do this, but if you do, I'm going to give you the formula. Thermometers measure degrees of temperature in either Fahrenheit, which is the customary measure that we use, or Celsius, which is the metric measure. Converting between the two measurements easily by following the formula outlined below. Temperature conversion, Fahrenheit to Celsius. Subtract 32 from the Fahrenheit number, multiply by 5, and then divide by 9. Weird. Multiply, then divide. Seems like a math riddle, and it probably is. Celsius to Fahrenheit. We're going to multiply the Celsius number by 9, then we're going to divide by 5, and then we're going to add 32 degrees. Weird. Personally, at my age, I don't comprehend the difference, but it's very important when traveling to another country. If you find out that in that country, like when I was up in Canada, that it was only going to be 15 degrees Celsius that day. Here's a question for you to ponder. Did I need a jacket? Enough about metric systems and U.S. measurement systems. In the kitchen, you can utilize whichever works for you, as long as your recipes are consistent. Do not mix and match systems. I do have some seniors who are using the metric system exclusively. They find it easier to measure. I also have seniors using the conventional US system. So it's whatever you're more comfortable with and whichever you'd like to use. We do have measurement devices for most everything in the kitchen because I want you to weigh anyway. Measuring and portioning. This is fun. The term measurement refers to how much of something is being used in a recipe. Ingredients can be measured in several ways. Most ingredients are measured by volume. Volume is the amount of space an ingredient takes up. For example, a salad recipe might call for 1 cup of pasta or 1/4 teaspoon of pepper. Other ingredients are measured by weight or heaviness, such as 1 pound of fish fillets or 2 ounces of butter. Yet other ingredients may be measured by the count or number of items, such as 1 medium banana or 3 egg whites. No matter how an ingredient is measured, careful, accurate measurement is necessary for quality and quantity control. And one of the things I want to add in here at this place, and it might come up a little later in the presentation as well, is weight is the most accurate. And I'm going to take the example of the each, a 1 medium banana or 3 egg whites. Well, if we just look at the 3 egg whites, 3 egg whites, depending on the size of eggs, a medium egg, a large egg, or an extra large egg, can mean 3 different weights. So it would be much easier if we knew that we wanted large egg whites, so it was 3 ounces of egg white. It would be much easier if it was written as 3 ounces of egg white. It's a weight measurement that it didn't matter what eggs we cracked to get our egg whites. We knew exactly how much egg white we needed. That's why weight is the most critical amount. It's the easiest and best way to measure for any culinary or baking recipe. For example, a cup of flour can weigh anywhere, depending on who cupped it, who put it in the cup, anywhere from 4.5 to about 6 ounces. Yes, it doesn't weigh 8 ounces. We talked about that before. It is not convertible. Okay? Volume to weight is not convertible. But it's important for us to know how much flour we need. So weight, if it was 5 ounces of flour on the recipe, there would be no question in anybody's mind when they took your recipe and made it how much flour was necessary. All right. Moving along. Volume is not as accurate a measure as weight. Wait a minute. It's like I just said that. Particularly for solids, because the nature of an item creates major variations in the amount of space it occupies. For example, 1 cup of water does weigh 8 ounces, but 1 cup of flour weighs approximately 3 to 4 ounces or 5 to 6, depending on who puts it in the cup. Depending on whether or not it's been packed, volume is often used to measure amounts of dry ingredients such as herbs and spices that are too small to easily and accurately weigh. Volume measurements is best used for liquids, but remember that even liquids can vary in weight in relation to volume. Always remember that the term fluid ounce is a volume measurement, not a weight. Only with water or water-like substances is 1 cup, volume measured, equal to 8 fluid ounces, volume measured. And to 8 ounces, example, water-like liquids in the kitchen includes milk, oils, thin liquids such as vinegars, and melted butter. So that 8 ounces is a cup. Okay, so a cup of water in the kitchen weighs 8 ounces. But that's only the thin liquids: water, oils, milk, vinegar, melted butter, things along those lines. Okay. Liquid measuring cups are see-through and have measurements markings on the sides. They're typically marked in fractions of a cup, fluid ounces, and milliliters. Customary sizes for measuring cups are 1 cup, 1 pint, 1 quart, and 1 gallon. Metric cups usually come in 250 milliliter and 500 milliliter sizes. Measuring spoons generally come in a set of 4 or 5. Most customary sets include these sizes: 1/4 teaspoon, 1/2 teaspoon, 1 teaspoon, and 1 tablespoon. Metric sets include 1 milliliter, 2 milliliter, 5 milliliter, 15 milliliter, and 25 milliliter measures. Weight is the measurement of an item's resistance to gravity. Weight is expressed in ounces and pounds. Like my resistance to gravity is pretty large. Think of the difference between a cup of popcorn and a cup of water. Both take up the same amount of space, but they do not weigh the same. The water is heavier. To find out how much each cup weighs, use a kitchen scale, not a measuring cup. Weight is often measured in ounces, while volume, as discussed earlier, is measured in fluid ounces. A food scale is helpful for measuring ingredients by weight. Scales are used to weigh ingredients for preparation and portion control. Both ounces, grams, and pound kilo scales are necessary. There's some videos in this module on weighing using scales. So please be sure to view those. When using a food scale, do the following. Decide in what container to weigh the food. Place an empty container on the scale. Adjust the scale until it reads 0, or the proper term for that is called tearing the scale. No, not tearing it in half, but tearing the scale to 0. Add the food to the container until the scale shows the desired amount. Once again, there's videos in this module that show you how to do that. Remember to correctly weigh an item and account for the weight of the container in which the item is located. This is known as tearing the scale. To do this properly, you should do the following. On a movable face scale, a spring scale, or portion control scale, place the container on the scale, then adjust the face back to 0. On a balance beam scale, which we have in the kitchen, place the container on one end of the scale, then place the tare weight on the other until the beam balances. Using the same container on the right and left side of the beam scale can help that. If you're using our flour baskets that we have on the balance scales, we have counterweights that match those flour baskets. There are a few different types of scales available for weighing food. Spring scale. The scale measures the pressure placed on the spring. An example would be a hanging scale used in the produce department of a grocery store. Weight is added to the hanging scoop, which pulls down the measure and the pressure placed on the spring. We used to have some of these in the kitchen. The kids destroyed them. So I've gone to just my balance beam and digital scales. Balance beam scale. Speak of the devil. Balance beam scale is also called the baker's scale. The weight of the item is placed on the one end and the product is placed on the other end until the beam balances. Scoops, counterweights, and pound measures are added to the scale, and ingredients are added to bring balance. Digital scales. Electronic scales measures resistance electronically. Digital scales are becoming more popular due to the portability and cost. You can get your own digital scale for use in the kitchen. I don't have enough for everybody, but if you want to get your own, Walmart sells those for about $12 these days. So they're really cheap. The batteries are, depending on the scale you buy, you want to check which scale you get and the availability of batteries, because I know that some of the ones we have in the kitchen use the CR32 batteries, which are not hard to get, but they're a little bit pricier sometimes than a AA battery would be. So that's a consideration to take into account. Measuring of fat. The best method of measuring fat, such as butter, margarine, or shortening, is by weight. Most professional bake shops recipes will ask for fat to be measured by weight. Some recipes may ask for fat to be measured by volume, teaspoons, tablespoons, cups, etc., or by 1/4 pound sticks. No matter which measure is required, it is important to always measure accurately. Measuring tips. Some recipes call for sifting ingredients. For example, flour, powdered sugar, and granulated sugar might need to be sifted. Sifting is a process that removes lumps from the ingredient and gives it a smoother consistency. Be sure to sift dry, powdery ingredients before measuring them. Never measure an ingredient while holding the measuring cup over the mixing bowl. If you overpour, the entire recipe might be ruined. So be very careful with that. Fill the cup with the ingredients. Some ingredients, such as flour and sugar, must be spooned into the cup lightly. Other ingredients, like brown sugar, must be packed down, but only if they're specified in the recipe. Level off the top of the cup using a straight edge spatula. Pour the ingredient into the mixture if needed. Use a rubber scraper to make sure all of the ingredient has been emptied out of the cup, particularly in things as shortening and butter, things along those lines that might stick in the cup. You want to get a rubber spatula in there and remove everything from that cup. When measuring liquid ingredients, set the measuring cup on the level surface. Carefully pour the liquid into the cup. Bend down to check the measurement at eye level for accurate reading. Add more liquid or pour off excess until the top of the liquid is at the desired measurement mark. Pour the ingredient into the mixing container. If needed, use a rubber scraper to empty the cup completely. For small amounts of liquids, use spoons, measuring spoons. All right, edible portion and as purchased amounts. EPAP is what it's known as. So edible portion is what's edible. As purchased is how we have to buy it. Let's take, for example, with Thanksgiving coming up in a month or so. Let's take a look at that Thanksgiving turkey. We have to buy the entire turkey. Bones, neck, all that stuff is part of the weight that we buy that turkey in. But the edible portion, the meat that we get out of that, is quite a bit smaller, as there's a lot of bone in the turkey. We usually only get about a 50 to 55% yield, as you will learn in a few minutes, is what we call that, out of a turkey. So our edible portion is only about half of what we purchase it at. That's a big example, but it's just one that maybe you can visualize there. All right. Most vegetables have to be trimmed and cut before being used in recipes. Almost no vegetables can be used 100% of its weight. As a result, cooks must calculate the correct edible portion, or EP, amount from the untrimmed, as purchased, AP amount. Think of such things, vegetables like a peel on an onion, or a leaf, or a stem. The edible portion is the amount of food item that's left to be cooked and eaten after the preparation, such as trimming and cutting. The as purchased amount is the amount of food item that was purchased before any preparation. For example, while the edible portion of purchased mushrooms will be close to 90%, only about 28% of corn on the cob is edible after the corn is husked and cut from the cob. It's a pretty good example. This shows an approximate variation of yields for produce items. Like a globe artichoke, whole trimmed, 80%, 30% for the bottoms only. Asparagus, 55%, green beans 88%, lima beans 40%, a beet 40 to 45%, 75% if purchased without tops, broccoli 65 to 75%, Brussels sprouts 80%, corn 28% after husking the corn, garlic 88%. There are charts out there that can walk you through yield amounts for various items. We have another one here. Looking at things like okra, white potatoes, radishes. And these are average yield amounts, but if you were to use these yield amounts, you would be pretty accurate in your costing. And yields with costing is very, very important. To determine how much of an item is needed as an as-purchased amount, simply divide the edible portion amount needed by the yield percentage. For example, a recipe of pasta salad calls for 4 pounds of cauliflower. The conversion chart showed that cauliflower has a 55% yield. To calculate how much will be needed to prepare 4 pounds of trimmed cauliflower, divide the desired edible portion amount by the yield percentage. Edible portion divided by yield percentage is equal to the as purchased. So 4 pounds of trimmed cauliflower divided by 55% equals 7.27 pounds of untrimmed cauliflower that's needed to prepare the 4 pounds trimmed. The cook needs to purchase at least 7.27 pounds of untrimmed cauliflower. The formula can also be used in reverse. For example, the cook has 10 pounds of untrimmed cauliflower, which has a 55% yield. As purchased times yield percentage equals edible portion. 10 pounds of cauliflower times 0.55 or 55% is equal to 5.5 pounds of trimmed cauliflower. That's how much we'll get from the cauliflower. In order to determine the as-purchased quantity needed to result in a given edible portion quantity, it is also important to know the cooking loss for the item. Many quantity cookbooks, purchasing textbooks, and yield books include charts of average cooking loss for common food items. A conversion chart is a list of food items showing the expected or average shrinkage from AP amount purchased to edible portion amount. These charts are tools that a manager can use, and they work well in most cases. However, it is wise to conduct your own tests periodically to get the exact as-purchased amount for your operation. A yield test helps to determine the amount of product that will be produced after required processing. A butcher test or butcher yield test is used to measure the amount of trim loss or shrinkage that occurs during the trimming of a meat product. This trimming includes deboning and removing fat and gristle. There are several kinds of trim to look for in a butcher yield test. Usable trim is a trim that is removed from the product but that may be used in a different way than originally intended. When trimming a beef tenderloin, the filet mignon steak, there is a small amount of meat that may be made into ground meat or stir fry. This would be an example of usable trim. Non-usable trim is the trim that is removed from the product and has no use in the restaurant. The gills or scales from fish are examples of non-usable trim. These tests are particularly important if the product is a high-cost item and if it is sold in high volume at the operation. If these two things are true, then the item can have a major effect on the operation's food cost percentage, which is the actual cost of food. A food cost percentage is the cost of inventory and purchasing divided by food sales. So nothing should be left to chance. For example, if prime rib is a house specialty, a conversion chart might not be accurate. There are many variables that determine the amount of shrinkage, such as length of time the product is cooked and at what temperature. Products today can frequently be purchased as an edible portion, usually known as convenience food. This is something that is purchased already trimmed and cut, such as pre-cut fries. The price of the item is higher, but prep time and labor costs may ultimately be lower. For example, a manager should weigh the amount of time saved peeling and cutting potatoes for fries against the cost of buying a product that comes already in that form. Costing recipes. Other factors that are essential to quantity food production are standard recipe costs, cost per serving, or standardized portion cost. To find the total cost of a standard recipe, you must know both the ingredient amounts needed and the market price of each one. Then multiply or divide the ingredient amounts by the prices and add it all up to get the recipe cost. Divide the total cost by the yield to get the standard portion cost. This shows how to calculate the standard recipe cost using the ingredients from the recipe in right here. So, chocolate, butter, egg, sugar, vanilla, cake flour, all those items measured, how much they cost per pound, the amount we need so that we can convert the total ingredient cost. And our bottom line is this is how much the recipe costs to make. Calculators make it easy to perform the calculations needed in the restaurant and food service industry. However, not all measurements are divided into groups of 10 for a convenient decimal. For instance, 1 ounce could be expressed as 0.0626 pounds, but it's more useful in the kitchen to know there are 16 ounces in a pound, and 1/16th of a pound is simply 1 ounce. Using the brownie recipe from this page, the ingredient weights can be converted to ounces, and then the cost per ounce can be used to figure out the total costs. So using this to convert to a standard where everything is measured by ounces makes it a lot easier for your ingredient calculations. So this makes it a little bit easier than the last one we had here, because you've converted it to something that's more easily done mathematically using a calculator, which are very much permitted for doing these kind of things. It is best when performing calculations to not round the cost per ounce prices until after performing the calculations. By not rounding, you get a truer and more accurate total recipe cost. After performing the calculations, ingredient costs are usually rounded to the nearest cent. Portion costs are originally carried out to 1/10 of a cent, the thousandths place to the right of the decimal. Now that you have determined how much it costs to prepare a recipe, what can you do with that number? The next step is to figure out how much it costs to prepare a serving or a portion. Most standardized recipes will state that the yield for the recipe. This information is necessary for figuring out the cost per serving or cost per portion. To determine a cost per portion, simply divide the total recipe cost by the portion yield listed in the recipe. This can be demonstrated by again using the brownie example from before. Total recipe cost is $30.44. Yield for the recipe is 96 brownies. Cost per portion is the total recipe cost divided by the yield for the recipe. So $30.44 divided by 96 is equal to 0.3170833, or a cost per portion of about 32 cents. Many operations price out all recipes and then check them every 6 months to see if they are still accurate. Some compare standard recipes to the National Price Index twice a year. If the index rises or drops a specific percentage, the total recipe cost is raised or lowered by this percentage, and the portion or yield cost is recalculated. While this method simplifies the recalculation process, restaurants and food service operations should really do a complete revision every year. Sometimes it's necessary to combine portion costs. A steak, for example, may cost $6.50 served by itself, but the cost increases to $10.99 when the steak is served with a salad, French fries, a roll, and butter. Some operations calculate the exact cost of each food item and then add the figures together to determine the total cost of a meal. Others simply calculate the average cost of all such extras and add this figure to the appropriate item. When patrons help themselves at a salad bar, there may be an extra calculation necessary to cost out a meal. The usual procedure is to keep an account of the cost of food in the salad bar and track the number of salad bar patrons served. Dividing the number of patrons into the cost of the salad bar will result in an average cost per serving. This figure can be added to the basic entree cost. For example, if an operation spends $95.68 per day to keep its salad bar stocked, and an average of 84 guests eat from the salad bar each day, the average cost per serving is $95.68 divided by 84, or $1.14 per serving. Costing can be somewhat complicated. However, the success and profitability of a restaurant or food service operation depends on balancing costs and prices. Costing recipes is something we're going to start this year, but I do not expect you to master for a while. So don't panic over this. And that concludes this presentation. It was a long one. I'm going to give you instructions in the beginning on how to break it down. If you read my instructions, you will not have listened to the entire hour all at once. Have a good day.